Here we're going to look at the temperature dependence of chemical potential for a single component, and in particular we want to compare the properties of chemical potentials for vapor and solid and the phase trends between the two. So the important equation is that the change in the Gibbs free energy, the differential change, is related to temperature and pressure. We're interested in the effect of temperature, so we're going to look at the case where pressure is constant, so this term is 0. For a single component, this is important, for a single component, the Gibbs free energy is the same as the chemical potential. And so we can see that as we raise the temperature, since entropy is a positive term, as we raise the temperature, the chemical potential decreases. And since the entropy of a vapor is greater than entropy of a solid, this means the chemical potential is going to decrease more for the vapor than the solid. Let's look at a plot of chemical potential as a function of temperature for a vapor and a solid. So we can see as we raise the temperature, the chemical potential of vapor decreases more. This particular plot corresponds to a relatively high pressure, so the entropy difference between the vapor and the solid is not too large. If we were at a lower pressure, the vapor would be decreasing much more for the same temperature change. The solid would not be affected very much. So remember, the component with the lower, the phase with the lower chemical potential is the stable phase. So at low temperature, the solid phase is stable, the solid line, and then at high temperature, the vapor phase, and the transition, the sublimation point, is where the two chemical potentials are equal, phase equilibrium. So note that this says the plot corresponds to the pressure less than the triple point pressure. And let's look at a pressure temperature diagram to understand why this is. So the triple point is here. In order to have solid vapor equilibrium as we change temperature, right? So as we raise temperature, go from solid to the vapor, we have to be at a pressure lower than the triple point. If we're at a pressure higher than the triple point, then the solid will go to the liquid as we raise the temperature rather than a vapor.